live here at NASA headquarters. We've got some exciting news on worlds outside of our solar system today. First, we'll have brief presentations from all of our panelists, and then we're going to answer questions from those in the studio, on the phone, and on social media. To ask a question via social media, please use the hashtag AskNASA. Today's participants are Thomas Zurbuchen, Associate Administrator of the Science Mission Directorate at NASA headquarters in Washington. Michael Gillon, astronomer at the University of Liège in Belgium. Sean Carey, manager of NASA's Spitzer Science Center at Caltech IPAC in Pasadena, California. Sarah Seeger, professor of planetary science and physics at Massachusetts Institute of Technology in Cambridge. And Nicole Lewis, astronomer at the Space Telescope Science Institute in Baltimore. And with that, Thomas, can you start us off with what the big news of the day is?
Hey, thanks so much, Felicia. Look, I've been Associate Administrator for the Science Mission Directorate for close to 5 months, and I've just been in awe, and I'm in awe today about both the depth and the breadth of the science that we do here. We're changing people's lives every day, and we enlarge in the space we know. We stretch our imagination, we inspire every day. And today's story is just that. I'm excited to announce today that Dr. Michael Gillon and his team have used our Spitzer Space Telescope to determine that there are actually 7 Earth-sized planets orbiting the nearby TRAPPIST-1 star about 40 light years away. What's more, as you can see in this illustration, is that 3 of these planets, marked in green, are in the habitable zone, where liquid water can pool on the surface. In fact, with the right atmospheric conditions, there could be water on any of these planets. So for the first time, we found as many terrestrial planets around a single star, and that's the first time we have been able to measure, in addition to that, both the masses and the radii of these habitable zone type Earth-sized planets. These planets are among the best of all the planets we know to follow up, to see, for example, with the James Webb Space Telescope that we're going to launch last year, the atmospheres, and also to look at biosignatures if there are any. The discovery gives us a hint that finding a second Earth is not just a matter of if, but when. Scientists believe, actually, that around every star there could be 1 planet. Take 3, take 5, take 7. And you can just imagine how many worlds are out there that have a shot to becoming a habitable ecosystem that we could explore. And what we really have in this story is a major step forward towards answering one of these very questions that are at the heart of so many of our philosophers, of what we're thinking about when we're by ourselves, and that basically is, are we alone out there? We're making a step forward with this, a leap forward, in fact, towards answering that question, and I'm really excited for you to hear about it now.
Thanks, Thomas. So, Michael, can you tell us more about this finding?
Sure. As Thomas mentioned, we used a Spitzer Space Telescope with over ground-based telescope to discover around the same star, not 1, not 2, but 7 Earth-sized planets. And this is the first time that so many Earth-sized planets are found around the same star. Furthermore, with 3 of them in the habitable zone. And the star itself is what is called an ultra-cool dwarf, which is the least massive kind of stars that exist. And these stars are much smaller, much cooler than our sun. And still, they are very frequent at the scale of our galaxy, more frequent than solar-type stars. And if you look at this illustration, you see the comparison between a basketball and a golf ball. Well, in our case, the basketball would be the sun, and the golf ball, it would be TRAPPIST-1. So TRAPPIST-1 is much cooler, much smaller than our sun, and so the planets in its habitable zone are much closer to it, very close to it, with very short orbital periods. And in these graphics, what you can see are the planets which were found around TRAPPIST-1, with the 3 of them which are in the habitable zone, so also called the Goldilocks zones, where liquid water could exist, is the most likely to exist at the surface of a rocky planet. having 3 of these Earth-sized planets in this habitable zone is very promising for the search for life beyond our solar system.
So what can you tell us about these distant planets?
Well, we have measured with Spitzer very, very precisely their sizes. And furthermore, we have, thanks to Spitzer 2, preliminary measurements of their masses for 6 of them. And for one of them, our measurement is precise enough to strongly suggest a water-rich composition, which is very exciting because this is one of the planets in the habitable zone. Furthermore, these planets are orbiting so